This is geotrig, day 2 of lesson 18, doing more of the word problems. Now we're bringing back again the reds, the blues, and the greens, and the whites, and all of that. Maybe we're talking about chips, we're talking about marbles, we're talking about something. Either way, we got things that are green, blue, and red, and all that stuff. Guys, they're going to just keep throwing different types of equations at you. Last time they said that something was twice as big as something else, or 7 more than something else. This time we're using the whole varies directly and inversely. I'm doing this with my Algebra 1 kids, at least the directly part. When I say something varies directly, there should be an equation that pops in your head. Does anybody know what the equation of something varying directly is? Direct variation. It's not greater than. Basically, things are directly related. As x goes up,
y goes up.
It
goes like there's an arrow and there's another arrow.
That's a line.
Yeah.
Okay.
You know,
If x goes down, then y will go down.
It's like that. And then
Its value. Y equals not mx plus b. It's actually, guys, before you guys would have learned slope-intercept form of a line. It's the almost the most simplistic line, because all it has is a slope. It has an x, you have a y, you have e equals, you have x, but they also use constant of variation. That is direct variation. So maybe after this, guys, or before it, put direct. If I wanted to know inverse variation, where y and x are inversely related, what would an inverse variation? It's a different one.
Yeah, I remember this. H. It's H.
There's no h in it.
Oh, it's not HK?
How about it still has k and x in it?
Is it KX?
It's not kx. Kx is direct.
one negative.
K over X.
K what? K over x. So if something is inversely related, it's y equals k over x. Guys, k is the constant of proportionality, or constant of variation. You treat k in the first one, y equals kx, like slope. That's nice. You should have learned that. That was like the first thing you did, because all of those go through 0, 0, and then I go up and over, up and over, up and over to move slope. Though y equals k over x, that's an inverse relationship. As x gets larger, y will get smaller. As x gets smaller, y will get bigger. It does the opposite, right? The inverse. Inversely related. So, you need to know those two equations, and unfortunately the fact that you can mix them to do this problem. The reds varied directly as blues squared, and inversely as greens. And then it goes in to tell you things about it. There were 80 reds when there were 4 blues and 2 greens. Some information. And then, to finish it off, tells you, hey, if I said that there are, how many reds would there be if there were 8 blues and 10 greens? So we're starting to make a different mix of colors, right? So, the first sentence gives us the equation. The second sentence gives us information of a green, a red, and a blue, which leaves only one variable left, the k. So you can solve for k. Once you know k, you put it back into the equation, and therefore I change up some information so you can find the remaining piece. But we have to go all the way back to what is the equation. What is the equation?
Y equals KX.
It's not y equals kx because we don't have y or x in this problem.
Oh.
Reds varied directly as blues squared.
Oh, so blues equals
So
K.
R equals
Yeah, blue, red.
K
B
B
squared.
squared. And at the same exact time inversely as greens. So over G. Now why does this work? How come I don't need an extra K in there? Is because the same K is used for both parts. The reds is directly, so that's on top, with the square of B, and inversely with G. All one equation. If you look at our information, we now know reds, blues, and greens. If you fill in all three of those spots, the only thing left is K. Solve for it. Fill it in. How many reds? 80 equals K times how many B? How many blue? 4 squared over greens 2. So 80 equals K times 4 squared? 16 divided by 2? So 80 equals 8K. Are you okay with that? So K has to equal 10. Divide by 8. Guys, this is not the equation. K equals 8 is not an equation. It's a variable. What do you think I should do with K equal 8?
Go plug that in.
Where?
For,
10.
no. Wait, why would you plug it?
Plug the K value into your equation. So now you have an equation that relates reds, blues, and greens.
Oh, gotcha.
So R equals 10B squared over G. There's your equation. Now that I have this equation, if I told you reds and greens, could you find blues? Yes. If I told you blues and greens, could you find reds? If I told you blues and reds, could you find greens?
Yeah.
Yes. So as long as I give you 2 of the colors, you can find the third one. Which ones do they give you? They give you blue and green. So I need to find reds, which is conveniently already solved for. R equals 10 times 8 squared over 10. Ooh, that's actually pretty easy. What happens to the 10s? Cancel. What's 8 squared? How many reds do I have? 64 reds. So the sum of the digits of a 2-digit counting number is 5. When the digits are reversed, the number is 9 greater than the original number. What's the original number? This is interesting. So you know we have a 2-digit number, right? So let's think of this. Let's just for fun. If I called this number 12, what does it mean to be 12? Well, it pretty much means 6th grade, no cares, right? Riding your bike around and playing Pokemon. But, oh wait, that was you guys this summer yet.
That's actually 17 there.
They targeted our age.
Actually, I had a car, so I was driving around.
At 12.
Same. You're driving around like
Okay, anyways. No, guys, the number 12, let's think about this. What are the digits of 12? 1 and 2. If I looked at 12 itself, I have a 1, I have a 2. Those are the digits. And so if I wanted to add the digits of 12, it'd be 3, because 1 plus 2 is 3. So if I added the digits, it's 3. If I reverse the digits, my new number would be 21.
Oh. I thought you meant like still add the 2.
Oh, that works.
That's 21. But this problem is actually asking us to find a number that's 9 more than the original number. Hey, wait a minute. That is 9 more, isn't it?
Wow.
But do the digits add up to 5? Yeah.
That's ridiculous.
Darn.
So maybe, we could guess and check. Maybe I should have went with 11 and that'd be 20, but those don't switch. 11 and 11 are their same digits reversed. That doesn't work anyways. So this actually probably isn't the easiest thing to guess and check either. Now, a lot of these problems, guys, like the money problem, you guys could have guessed. You could have took 20 coins and figured out a combination to get to $1.90. But there's got to be a better way than this. But you guys get the idea that if I wanted to add the digits, this would be 1 plus 1, that'd be 2. Right? Okay. So adding the digits is not that big of a deal. What if I didn't know the number, though? I'm going to take these away. What if I didn't know the number? What if I didn't know the number? What can I call it?
X.
Well, here's the thing. It's a 2-digit number, so I can't just use it, call it X.
X and Y.
I could call it XY, but we use X and Y a lot for other things. So you guys want to use AB? Okay.
Oh, you guys are so boring.
Q and B.
How about M?
Here's your 2-digit number. This is the, I'll call, old number. Or the, or say, maybe use the words they're using.
Those are my first two initials.
Oops. The original number, yes? Our new number would be what? BA. Okay? You guys okay with this?
Yeah.
What would the digits of our original number and actually the new number add up to be? So you're saying that add them up, that A plus B would be adding the digits. Hey, wait a minute. It told us something about that. It has to be 5. We got one equation. But how many variables do we have? We have 2 variables. 1 equation. Is it enough to solve?
No.
No. The rule was the amount of variables you have, you need to have at least that many equations. So what's the other connection?
A minus T.
The new number is
Greater than
9 greater than the original, right? So how many of you guys just go, oh, not a big deal. So that means that BA equals AB, that's bad, okay, AB plus 9. Right? The new number, new, is equal to the old number plus 9. Here's a problem. What does number AB or BA even go? Okay, let's go back to 12. What is 12 that makes it 12? It's a 1 and a 2, but it's not a 1 and a 2. It's a 10 and 2 ones. Yes? 12, guys. Hold on. Okay, let's go back into this. 12 is a representation of 1 10 and 2 ones. So it's 1 10 plus 1 or 2 times 1.
No, it's not.
It just have like 12
Could-
ones.
I'm trying to think of the right words to say this.
You got 5 twos.
Yeah, 5.
Can you do 5 twos and 1?
Yeah, 5. No.
You
Well,
can do 5 twos and
You can. But if I'm looking at number sense, guys, number sense, each number has a placeholder.
yeah.
We start off with the ones, then we go to tens, then we go to 100, then we go to thousands,
100,000.
No.
No, 10,000.
10,000, 100,000. Okay? So when we say 128, it really means that I have a group of 100, 2 tens, and 8 ones. That
Yes.
gives me 128.
Yes. That makes sense.
Okay. Let's take this away. I don't know my number. Here's my number. It's B or AB. If I wanted to know its value, using well, I'll put it back on here. Using this idea of 12 from here, how can I change AB into an actual number sense instead of just being representation of AB? How many tens do I have?
1 and 1.
A, tens. How many ones?
B.
B. 10A plus 1B would be the value of AB. What's the value of my new number? 10B plus 1A, or just A? Because think of what 10 or a 12 or a 24 represents. It's just a 2 and a 4. But the 2 represents 2 times 10, and the 4 would represent 4 times 1. 24. Because it's in a 10 spot or 1 spot. So the question is, it's not B times A, because that means if this number was 24, it'd be 2 times 4, which is 8. Is that 24? No. So I don't want to use this. That's not right. I think this is the right setup, as in the new number is the old number plus 9, but the value of the old number is 10B plus A. The old number is 10A plus B. So we got to take this out. We need to say that 10B plus A is equal to
10A plus 1B plus 9.
yes, 10A plus B plus 9. I have to actually give it value, not digit value. Remember, down at the bottom here, 12. It's not AB, if this is 12 and that's AB, it's not AB as reversed is 2, 1. We're not talking about 2. 1 times 2 or 2 times 1. We're talking about the value of 10, 110 plus 2, which is 12. You got to give it a value. You now have 2 equations, 2 unknowns. The top one's in standard form. A plus B equals 5. Can you place the bottom one into standard form? I'm going to fix this. That's an A, not a 9. Do you think that if we got these A's and B's to this side, that would help us?
Yeah.
Because then it'll be in the same form as this. Subtract 10A. Subtract B. Subtract B. 9B minus 9A equals 9. I am going to place this equation and that equation together.
Oh,
So what can I do? I could use substitution. I could solve for B or A and then plug it into the other equation. Nah. They're in standard form. Use elimination. You could take a 9 out of the bottom one. Or could I just multiply the top one by 9?
We have to do it for both sides.
Correct. Would you agree that this would be 9? Oh, they're not even in the same order. Uh-oh.
Just do negative 9a plus 9b equals 9.
No.
Nice try, John.
This is A plus B. This is B minus A. Does that really matter, though?
No.
So when I go to multiply this 9 in,
It's going to be the same thing.
that's 9A over here, right? Positive. But it's also a positive 9B when I go here. And then equals
45.
45. 9B plus 9B is
18b.
18B. I'm going to get rid of this stuff. We don't need this anymore. What happens to the 9A's? Cancel. Equals 54. Can you divide both sides by 18? So B is equal to 3. If you know B is 3, what does A have to be? 2. So, going back up here, A plus 3 equals 5. A equals 2. B equals 3. The question's not asking you what A or B is. It's asking what the the original number was AB, which is 23. Done.
Didn't somebody say
Homework, guys, is page 137, 3 through 5. Have a great day.